Simplify exponential expressions and growth and decay. Now, you've seen the previous video, or if you haven't, watch it. These ones are a little bit more challenging. Let's see how we apply these. There are multiple different ways that you can do these kind of problems. So I will give you one, maybe two, depending on the problem. We can apply the multiplication. This rule is to the first. We have an exponential to a power, so we're going to multiply the exponents. This is 2 to the negative 4th times x to the positive 12, because 1 times negative 4 is negative 4, and negative 3 times negative 4 is 12. 2 to the negative 4 is 1 over 2 to the 4th times x to the 12th, so this gives us x to the 12th divided by 16. We could have also done it as, and although I wouldn't recommend in this one, this is the same as 1 over 2 to the x to the negative 3 raised to the 4th power, which is 1 over 2 to the 4th x to the negative 12. 2 to the 4th is already on the bottom. That's a positive exponent. We leave it there, so it's 1 over 16. And 1 over x to the negative 12, we'll take the reciprocal of that, and that becomes x to the positive 12. And we get our same answer, x to the 12th over 16. On the next one, we have, note the similarities between these, but how different the answers are going to be. Over here, everything's multiplication. There was no raising everything to a power, so it's just 2, and then x to the negative 3 times x to the negative 4 would be negative 3 plus negative 4, or 2 times x to the negative 7. I'm showing this step right here, but it's not essential. Similarly, it would be 2 times 1 over x to the 7th, and this is 2 over 1 if you needed it, which would be 2 over x to the 7th. Again, this step here isn't really needed, nor is this one. On the next one, we have x to the negative 2 times x to the negative 3. All of that raised to the negative 1. So we're going to simplify what's in our or in parentheses before we apply our exponents. So this is x to the negative 5. We have the same base. It's multiplication. We're going to add the exponents. Raised to the negative 1. We apply the negative 1, which we were multiplying, so it's negative 1 times negative 5, and we get x to the 5th. On the next one, take a look at number 4 versus number 3. They're very, very similar, except we have a plus versus a multiplication, which is a huge difference in this problem. Now, when I come back to this number 3, I could have said that this is x squared, I'll put here, or times x cubed, and that gives us x to the 5th. If I try to do that in this problem, it's automatically wrong, and it'll give you 0 points for the problem. You cannot do that at all. What you must do is simplify in here, and the reason why you can't do it is because of this plus sign. That plus sign is basically saying no. Recall, for just a second, I'll put it up here, if I have a triangle like this, and I say this is 3, 4, and I ask you find x, you all know that the answer is 5. But if I use the Pythagorean theorem, I'd say 3 squared plus 4 squared, and take the square root of it, equals what x is. Now this square root is an exponent of 1/2. Can I say that this is 3 and just multiply 1/2 times 2 and 1/2 times 2 and get 3 plus 4? No, you know that's wrong. Similarly, in this problem, you can't do that. You must simplify what's in the expression to get one number. For example, up here we'd say 9 plus 16 and give us 25 to the 1/2, and that'll give us 5. The square root of 25 is 5. When I take a look at this one, I need to get this to one thing. So one fraction. This will be 1 over x squared plus 1 over x cubed raised to the negative 1. My common denominator here, this is x times x, and this is x times x times x. So we have 3x's multiplied, 2x's multiplied. So what I'm going to do is multiply this first one by x over x. So I will get x plus 1 over x cubed. All of that raised to the negative 1 power. Now I can apply the negative 1. It says whatever is being raised to that power, I'm going to flip the fraction and make it positive. So it's x cubed over x plus 1. This next one, we have 8 n to the 4th minus 4 over n squared. Notice only n is being raised to the negative 2 power. You cannot insert you cannot insert parentheses here just because you feel like it. If it said 4n in parentheses raised to the negative 2, it'd be 1 over 4n raised to the second power, but it's only n in this case. And this is 2 over n to the positive 2 now, sorry. So now what we're going to do, there's a couple ways we can go about this. When I see a multi-layer fraction like this, what I want to do is clear all the fractions, just like when we're solving equations. So I'm going to multiply the top and the bottom by n squared, which is the least common denominator of every single denominator, every single fraction that's in this problem. When I do that, I get 8 n to the 6 minus 4 divided by 2. And now this 2 must be distributed to both of those, and we get 4n to the 6 minus 2. Now let me show you another way I could do this one. I could have done this, so I'll put it or, put a little space here. 8n to the 4th over 2n to the negative 2 minus 4n to the negative 2 over 2n to the negative 2. 8 divided by 2 is 4. N to the 4th divided by n to the negative 2, so 4 minus negative 2 would be 4 plus 2, which gives us n to the 6, minus n to the negative 2 over n to the negative 2 is 1, so we just get 2. Now be careful of thinking, oh, this one's so much better because it's shorter. This idea here of multiplying by a 1, basically, something over itself, to get a nicer fraction is a great idea, and we're going to need to use that often. Next one, what we want to do here is get a common base. I have a base of 4, 8, and 16. What could they all be written with? They could all be written as 2. So this is 2 squared to the 9th times 2 cubed to the negative 4th over 2 to the 4th to the 3rd, because 2 squared is 4, 2 cubed is 8, and 2 to the 4th is 16. Now I can apply all my rules since I have a common base. This is 2 to the 18th times 2 to the negative 12 over 2 to the positive 12. Be careful that these things are not the same thing. A negative exponent and a positive exponent do not simplify. On the top, I'm going to have 18 plus negative 12, which will be positive 6, over 2 to the 12th. And that will simplify. You can do this multiple ways. One way to do it is to say 1 over 2 to the 12 minus 6, or 2 to the 6, and that will give us 1 over 64. As long as this is a small number, I'd say multiply it all out. If it's a big number, don't worry about it. Let's say it was 5 to the 10th power. Then I'd say that's too big to even worry about. Note, I could have said that this is 2 to the 6 minus 12, so it would be 2 to the negative 6, but 2 to the negative 6 is equal to 1 over 2 to the 6, which still gives us 1 over 64. Next one, we have all three different bases. Let's write them with the same base. So this would be 5 cubed to the n, and this is already 5 to the 4n, over 5 squared to the negative n, and this cube root is the same as the 1/3 power. Now we need to simplify this. This is 5 to the 3n times 5 to the 4n divided by 5 to the negative 2n. And again, we have negative 1, or positive 1/3 power, sorry. So on the top, we'll have 5 to the 7n divided by 5 to the negative 2n to the 1/3. 5 to the 7n minus negative 2n, which will give us a positive 9n. And now 9n times 1/3 will be 5 to the 3n. Over here, this is 1 over 3 squared divided by 1 over 3 cubed plus 1 over 3 squared. Now you could multiply this out and say 27 and 9 and 9, or you could do it right away and say, just like I did on problem 5, what could I multiply by that would get rid of every one of these fractions? 3 to what power? 3 to the third power. When I do that, 3 to the third power divided by 3 squared will give us 3. 3 to the third divided by 3 to the third is 1. And 3 to the third times 1 over 3 squared, or 3 to the third divided by 3 squared, will give us 3. So this gives us 3/4. If you combine fractions, flipped and multiplied, it would eventually work out to be the same thing. It just takes a little bit more work. Now I'll show you this one two different ways because people just forget on dealing with this. This x to the negative fourth is 1 over x to the fourth, and then y minus 1 over x squared. If I multiplied by the LCD, which would be x to the fourth here, x to the fourth over x to the fourth, I'd be left with x to the fourth y squared minus 1 over x to the fourth y minus x squared. Now I can factor this. How would I factor that? I can see that the bottom has a common x squared in it. So this would be x squared times x squared y minus 1. The top, what you have to recognize is that this is a difference of squares. It's a little easier to see here, but I'll show it in the previous one as well. This is x squared y minus 1 times x squared y plus 1. Remember, we're using the rule a squared minus b squared equals a minus b times a plus b. That's a factoring difference of squares. So over here, we can reduce, and we're left with x squared y plus 1 divided by x squared. And you can leave that as your answer. Now, some might say, hey, I can see this earlier. I can see this in the first stage, that this is y minus x to the negative 2 divided by y plus, or times y plus x to the negative 2, all divided by y minus x to the negative 2. We can reduce y minus x to the negative 2, and we're left with y plus x to the negative 2, which I don't want you to leave the negative exponent. You can write it as y plus 1 over x squared. If we were to divide this by the x squared y over x squared gives us y plus 1 over x squared. These are equivalent. It doesn't matter which one you use. Let's go on to number 10. What I want to do in this one is I want to deal with the fact that